Okay, we're starting 410, the very last section in this chapter. So now we're going to take everything that we know about given a function equation and making a graph or finding the minimum or the maximum. Now we're going to be given a graph and we're going to write the function. So this first example, if you want to pause the video and draw it yourself, that would be a great way to start. So pause it, jot this down. There's a vertex here at 1, -2. We have a point on the graph that's at 3, +2. All right, so on the left-hand side, I've got a reminder of 3 forms of a quadratic. These should feel very familiar to you. The standard form, y equals ax squared plus bx plus c. We use that for the quadratic formula. Vertex form, where you can just pull out the vertex as h and k. An intercept form where you have it all factored out, and then it would tell you the x-intercepts. Note in all of these, all 3 of them, the one thing they have in common besides x and y is a. So in order for us to write the function for a quadratic, and really for most of our functions that we're going to see soon, we need to know something important about it. In this case, we have the vertex. And we also need to know how fast it grows. So this second point tells us whether this is a skinny parabola, the parabola that goes through 3, 2, or some wider parabola. It tells us how fast it grows. So we need both a vertex and a second point for the stretch factor, otherwise known as A. So vertex and stretch factor. With those, we can write the equation for this particular quadratic. That A value, if it's positive or negative, will tell us if this goes up or down, and then it'll tell us how fast it grows as it goes up. So, given that we have vertex in this particular one, we're going to start with the vertex form of the quadratic. So I'm going to write that down first. Y equals A, x minus, and the vertex has a 1 here, so 1 squared minus 2. The k value is always the same as h. So the vertex is h comma k. But here it goes in as opposite math. So I have almost everything I need already to write this equation. The one thing I need to know is the stretch factor. In order to find that, I'm going to use the second point, 3, 2, and I'm going to use it as an xy point. So I'm actually going to plug in 3, 2 into this equation and see what a equals. Right now I have y, a, and x is all things I don't know. And so if I plug in x and y, the one thing I'll be able to figure out is a. So y is 2. I don't know a yet. X is 3. I'm supposed to plug that in. 3 minus 1 squared minus 2. I rewrote the entire equation except put x and y in. Now we're going to solve this. 2 equals a times 3 minus 1 is 2 squared, 4 minus 2. I'm going to add 2 to both sides to get rid of this one. I have 4 equals 4a, so a equals 1. So the exact equation for this parabola is y equals 1. If you want, you can put it in there. X minus 1 squared minus 2. Vertex and stretch factor. So given those 2 things, we would start with vertex form. I'm going to draw the second one out, and then we will do a second example. Example 2 is a down parabola, so that already tells me something about my equation. I have 3 things given in this graph. I have the places where it crosses the x-axis, and I have another point that will help me figure out stretch. So when we first saw this kind, where we had the y-intercepts here, we found the vertex by finding the middle of that. That would be this point, the high point. And then the stretch factor we could find from there. But I don't know exactly what the height is of this vertex because I don't have an equation yet. So I'm not going to go quite that route yet. What I do know is that this is a point. It's -1, 0. And this is a point. It's 4, 0. And these are x-intercepts. So that tells me that if I use the intercept form, which is y equals a times x minus p times x minus q, these being the x-intercepts, I can plug in these values with opposite math and have the most of my equation ready to go. So y equals a, I still don't know that. That's going to be the stretch factor I'll figure out in a minute. I do know that a will be negative, but that's all I know right now. And then I have two intercepts. One of them is negative 1. So this means x equals negative 1 and positive 4. You get these values with opposite math. That's why it says x minus p and x minus q. So in order to have x minus 1 as a factor, it has to be opposite math, x plus 1. And 4 to be opposite math has to be x minus 4. And when you see it like that and check it, it does make sense. If you were to solve those equal to 0, they would be correct. So I'm going to transfer them up here, x plus 1, x minus 4. The only thing left to solve is a. I'm going to do it just like I did in the last example. I'm going to plug in my secondary point or secondary piece of information, and then I'll be able to find a. So y is 2, x is 3, so that's 3 plus 1, and 3 minus 4. 3 plus 1 is 4. 3 minus 4 is, 3 plus 1 is 4, and 3 minus 4 is negative 1. So 4 times negative 1, that gives me a times negative 4, divided by negative 4, and the a value equals negative 1/2. So I can put it back into this original equation and say that the graph for this one is, or the equation for this one is, negative 1/2 x plus 1 x minus 4. So you have to look at what you're given in the graph, figure out which equation that we'll use, and then plug in from there. Example 3 is, what if you're just given 3 points, not necessarily vertex or intercept? So I don't know if any of these are the vertex or the intercept. I just don't know that yet. I could plot them and have a fair idea of what it looks like, but I don't have any that are equidistant from the axis of symmetry. I know that because I don't have any of the same y values. So what we're going to do instead, actually let's look at it just to see what it looks like. 2, 1, 2, 3, 4, 5, 6, that's a point. 0, 1, 2, 3, 4, and negative 1, negative 3. Okay, so I have a fair idea. It's going to go up and down like so, but I don't know exactly what the equation is. Given that I don't have the vertex or an intercept, I'm not going to use either of those equations on the left-hand side. I am going to use the standard form, which I'll rewrite here, y equals a x squared plus bx plus c. And I don't know a, b, or c. So instead what I'm going to do is plug in this point for xy, and then this point for xy, and then this point for xy, and I'm going to have 3 equations with 3 variables that I'm going to solve for. This takes us back to an earlier chapter when we had to solve for 3 variables. So let's see what that does. If I plug in negative 1, negative 3, I have negative 3 for y equals a times negative 1 squared plus b times negative 1 plus c. 0, negative 4 means I'm going to have negative 4 for y. And then 0 means that 0 times a and 0 times b, they disappear and I just have c. The third one, if I plug in 6 for y and then 2 for x, I have a times 2 squared plus b times 2 plus c. So I have 2 equations with a, b, and c, and I have one with c already figured out. So I'm going to do this first. I'm going to rewrite this one as negative 3 equals a minus b plus c, just doing the math for the negative one. I'm going to do this one. It's going to be 6 equals 4a plus 2b plus c. And I already know what C is, so it's -4. I can go ahead and plug that in as well. So I'll do that right here. -4. Then this first equation simplifies to still being something where I add 4 to both sides. That's going to be 1 equals A minus B. The third one is going to be add 4 to both sides. 10 equals 4A plus 2B. And now I have two equations and two variables. I can use either substitution or elimination in order to solve for A and B. I already know what C is, so if I know A and B, I'll be able to write this equation right here. I'm going to do that on the side. I've got 1 equals A minus B. I've decided that I'm going to take this one and I'm going to divide it by 2 so that I have 5 equals 2A plus B, because then my B's will cancel. That gives me A plus 2A is 3A equals 6, therefore A equals 2. If A equals 2 and C equals -4, I can plug into one of my equations and figure out what B is. So here we go. I'm going to use this equation. -3 equals A, which is 2, minus B minus 4. I have -3 equals -B minus 2. Add 2 to both sides. -1 equals -B, so B must equal 1. And now I have A, B, and C, and we can rewrite the equation out so that we have y equals 2x squared. Y equals, right here, A is 2. 2x squared, B is 1, plus B is 1, so I want to write 1x, and C is -4. So now I have it in the form where I have ax squared plus bx plus c. So we had to use substitution to get 3 equations, 1, 2, 3. We called these A, B, and C before. 3 equations, and then they simplified a little bit, so all we had to do was a simple elimination in order to figure out what A, B, and C were. And this is the quadratic that we were looking for that has all 3 of these points as A, B, and C. Okay, I've got 2 examples that I want you to try on your own. Then I'm going to work through them with you so that you're ready to work on your homework. And we'll do one more with the A, B, and C in just a sec. So try these 2, pause the video, work them on your own, come back, and we'll have solutions ready for you. Okay, here we go. If you're not finished, pause it again and finish up. This is going to be vertex form, so I already know y equals A times x minus 4 squared minus 5. Please don't forget the squared. Students are so excited that they have the form sometimes they forget it needs to be a quadratic and have the square here. So now that I have the foundation for it ready to go, I just need to know the stretch factor and whether it goes up or down. So I'm going to plug in -1 for y, 2 for x. -1 equals A times 2 minus 4 is -2 squared is 4 minus 5. Add 5 to both sides. And so I have 4 equals 4A and A equals 1. Now my equation is y equals, it's this equation, except it's going to be x minus 4 squared minus 5. The A value is 1 for this first example. Not maybe as exciting as I'd hoped, but simple to solve. The second equation is y equals A, opposite math, x plus 2, x minus 5. I'm going to plug in the second point. So the y value is 2. The x value is 6. 6 plus 2 is 8. 6 minus 5 is 1. I have 8a, so I'm going to divide by 8. And I have 1/4 equals A. The final equation is y equals 1/4, x plus 2, x minus 5. So this is a puzzle. You're given different pieces. You have to figure out which puzzle you're going to plug it into and then solve and simplify your math. Okay, your third example, you're going to need to make 3 equations, one for each point. They'll have A, B, and C in it. Solve for A and B and C and rewrite your equation in standard form. So pause the video and write these vertices down, not vertices, write these different points down and then find the equation for your quadratic. Okay, so here we go. I'm going to have y equals, I'm going to have 5 equals negative 1 squared, so that's A, minus B plus C. So that was negative 1 squared, negative 1, and no x value at all. Second equation, negative 1 for y, 0 for x, so no A or B, and this is C. We've already found C. And then 11 equals 2 squared, so 4A plus 2B plus C. So I'm going to do the same thing as last time. I'm going to plug negative 1 in. That gives me 5 equals A minus B minus 1. And that simplifies to 6 equals A minus B. So I'm going to work with this one in a little bit. I'm going to simplify this to 11 equals 4A plus 2B minus 1. So that's 12 equals 4A plus 2B. And again, I'm going to divide this one by 2 and then put it up here. So that'll be 6 equals 2A plus 1B. Add these together, 12 equals 3A. A equals 4. And if A equals 4, I'm going to plug in here. 5 equals 4 minus B minus 1. That's 5 equals 3 minus B. 2 equals negative B. B equals negative 2. When I put A, B, and C in my equation, I then have y equals A x squared. And I wrote A again. A x squared plus negative 2x plus c. And it might be easier to write it in standard form above and then just substitute in underneath. So A is 4, B is negative 2, C is negative 1. You can see it really clearly right there. Okay, so 3 equations and then simplify. Good luck with these problems. Holler if you need any help. And we will finish out this chapter with some overall chapter review. And these last 2 sections really tied everything together for us. So we graphed in the last section and shaded. We did systems of equations where we shaded for 2 different equations. Now we're writing equations again and looking over here at standard, vertex, and intercept form. So I really want all of those different forms to be solid for you. Practice those, make note cards for studying, and let me know what questions you have.